Welcome back to the deep dive. Today, we are cutting through all the hype around these huge frontier AI models to ask a really simple question.
A critical one.
Yeah, how well do these incredibly complex systems actually handle the mundane stuff, the everyday tasks you actually use them for?
Things like shopping, fixing a leaky faucet, figuring out what to make for dinner tonight.
Exactly. And the scale of consumer AI use it's just staggering. You see it everywhere. I mean, look at the numbers from mid-2025.
They're huge.
61% of American adults had used AI in the last 6 months, and almost 1 in 5 of those people, 19%, are using it every single day.
And that daily use, that's not happening in some boardroom. It's happening in, kitchens and living rooms. Daily messages to ChatGPT, for instance, just exploded.
Exploded is the right word.
Yeah, from about 450 million to over 2.6 billion in just 1 year. And get this, 73% of those messages were totally non-work related.
That's a huge amount of consumer reliance. And it translates directly into money. Bain & Co. thinks consumers are already spending something like $12 billion a year on AI.
But here's the massive contradiction, and this is what we're really diving into today. Despite all this usage, all this spending, the public is still profoundly skeptical.
They don't trust it.
They just don't trust it. Can you rely on the price it gives you? Is that recipe correct?
Yeah.
And the traditional benchmarks are terrible at answering that. They test abstract reasoning or coding.
Right.
Not whether the AI can buy you a birthday gift on a budget.
Which is the whole point for most people. If an AI can, pass the bar exam but can't find a working purchase link for the product it recommends, what good is it?
Exactly. And that's the gap this new research aimed to fill. They introduced something called the AI Consumer Index, or ACEV1.
A totally new kind of benchmark.
A new benchmark designed specifically to see if these models can meet real, grounded, everyday consumer needs.
Okay, let's unpack this. Our mission today is to understand how this index was built to basically catch models in the act of lying, what we call hallucination, and to figure out which areas are the biggest reliability risk for you, the user.
So when setting up ACE, the researchers knew they couldn't just create another, abstract test. They needed real-world complexity.
So what did they do?
The main test set, they call it ACE V1, held out. It has 400 hidden test cases, and they're split perfectly. 100 cases for each of 4 key consumer domains.
And those domains are?
Shopping, DIY, so do-it-yourself, gaming strategy, and food preparation.
And I saw in the source material, they didn't just make up these prompts. The quality control here was intense.
No, absolutely. To create these 400 cases, they brought in 47 actual subject matter experts.
Not academics.
No, not academics. We're talking professional chefs, personal shoppers, master tradespeople, even game developers. People whose jobs depend on getting the details right.
And that led to a really high bar for what a good answer looks like.
A very high bar, yeah. It was reviewed through 3 strict layers of quality control. But I think the structure of the prompt itself is what makes ACE so clever. Every single task includes a detailed persona.
Okay, tell us more about that. Why is adding a persona so important?
Because it forces the model to move beyond just generic information retrieval. It has to start managing complex constraints. You aren't just asking, what's a good gift?
You're asking something more specific.
Much more specific. You're asking for, say, a laptop recommendation for a 30-year-old on a tight budget buying a gift for his brother who plays Total War. The model has to get the age, the budget, the purpose, and the specific gaming compatibility right.
If it misses any one of those things, the whole answer is useless.
Completely useless.
That's incredibly smart because that's just how people talk. We assume the AI gets all the implicit stuff, but I saw they found a problem with that at first.
They did. It was a fascinating refinement. Initially, the models were failing because they just couldn't guess those implicit expectations, even with a persona.
So what happened?
They realized they basically had to hold the model's hands. The pure, simple prompts were, well, too simple. A model would give a great recommendation, but forget to include a purchase link.
The most basic thing.
The most basic thing. So to make it fair, the researchers actually appended explicit, customized instructions to the end of every single prompt.
So for a shopping prompt, they literally had to add a little note saying, P.S. The user expects you to include the purchase links and prices if you can.
That's exactly what they did.
Wow. That just shows you how much these AIs struggle with basic user expectations. It's like it needs a tutorial just to function.
Precisely. And the complexity of these requirements, they varied a lot across the 4 domains. If you look at the criteria breakdown, DIY tests were by far the heaviest lift.
More complex than the others.
Way more. They averaged over 10 specific criteria per task that the model had to meet. I mean, it makes sense. DIY involves physical steps, materials, safety warnings. It's just inherently more complex.
Right. Assembling a bookshelf has more unique steps than finding a good recipe. Okay, now let's talk about the grading. This is where it gets really interesting, because they designed a system to stop what they call reward hacking.
This is the core of their hierarchical scoring. They start with something called hurdles.
A hurdle.
Yep. Think of a hurdle as the absolute non-negotiable goal of the prompt. If you ask for a recipe for coq au vin, and the model gives you a fantastic recipe for beef stew, you've tripped the hurdle.
Because the poor intent was missed.
Exactly. If the model fails that hurdle, the score is immediately 0% for the entire task. It doesn't matter how well it described the beef stew. It's a gatekeeper.
And if the model clears that hurdle,
Then the real fun begins. Because this is where the system starts to account for factual dishonesty, hallucinations.
the grounding checks. This is the really novel part, especially for shopping and gaming.
That's right. For any empirical claim, so anything factual like a price, a product feature, an availability date, the criteria has to be checked against a real, retrieved web source.
So we're talking about real-time fact-checking.
Real-time fact-checking. And the data shows this was absolutely critical for those high-stakes domains. Over 74% of shopping criteria required a grounding check.
74%.
And 42% of gaming criteria did too, because they involve these external, constantly changing facts like prices or specs.
Whereas DIY and food, which are more about general knowledge, how to hammer a nail, how to poach an egg, they just use standard positive scoring.
Correct. And this is where the scoring moves from being just tough to being outright punitive. We are not just talking about failing to earn a point. We're talking about models losing points.
And getting negative scores.
And potentially receiving negative scores overall.
Wait, negative scores? How does that even work?
It's designed specifically to punish fabrication. If a model makes a factual claim, let's say it gives you a price, and that claim is not supported by the web source, meaning the model just made it up,
It hallucinated it.
it scores -1 for that criterion. If it meets the criterion and it's factually supported, it gets a +1. If it just fails the criterion without making a false claim, it scores a 0.
So a negative score means the model is actively misleading the user.
Actively detrimental. You're being penalized for appearing helpful while fabricating facts.
That is a fascinating and incredibly tough standard.
And it gets even more extreme. If a user asks for, say, 3 budget laptops, and the model gives 3 great options, but the price on just one of those 3 is hallucinated,
The whole thing fails.
the response fails the grounding check for that entire criterion and gets the -1 penalty. This benchmark is absolutely brutal, but you can see why it's necessary to ensure consumer trust.
Okay, with that incredibly rigorous methodology in mind, let's get to the results. What did ACE actually reveal about these frontier models?
Well, the results were, frankly, underwhelming. Looking at the overall leaderboard, the top-performing model, GPT-5 High, which you can think of as the most advanced premium version, only got an overall score of 56.1%.
56.1, that's barely passing.
It was narrowly followed by O3 Pro at 55.2 and GPP 5.1 at 55.1.
So the big headline here is that the very best AI model available fails at typical consumer tasks almost half the time.
That's one key takeaway. The other is the huge difference in performance across the 4 domains. The models clearly struggle much more with certain types of tasks.
Let's get into that domain gap. Where did the models do best?
Food. The food domain was by far the easiest for them to handle. GPT-5 scored 70.1%.
Okay, so a C-.
Right. And food tasks rely heavily on, structured internal knowledge, recipes, ratios, processes. This stuff doesn't change every day.
And the worst performing domain was shopping, which is a huge deal since that's such a high volume
A
activity.
huge deal. Shopping was the hardest domain, where the top score from O3 Pro was only 45.4%.
Wow, that is a massive drop from the 70% success rate in food.
It is. DIY and gaming were kind of in the middle, around the mid-50s and low 60s. But the reason shopping is so difficult, we believe, is that it's so heavily tied to those brutal, real-time grounding checks.
So the models are good at telling you how to do something, like a recipe or DIY steps. But they're terrible at telling you what to buy, where to buy it, and for how much.
And that 56% overall score, it just confirms there's this monumental reliability gap between what these tools can do and what consumers expect.
And that gap becomes really, really clear when you look at the grounding failure analysis.
Yeah, this part is shocking. The researchers compared the model's pass rate on all criteria versus its pass rate on just the criteria that required that factual verification.
So I'm guessing a big negative difference there means the model sounds really confident, but is just making stuff up.
Precisely. A negative difference means the model is superficially good at generating text that looks right, but it's highly prone to hallucinating the key information that actually makes the response useful.
So which model was the biggest offender here? Who was the worst?
The data points directly to Gemini 3 Pro High as the least grounded model. Its performance dropped a staggering 27.6 percentage points when its claims were fact-checked.
27 points.
The researchers concluded it likely prioritizes generating text that sounds helpful, even if it means, and this is their phrase, hallucinating key information to appear helpful.
Wow. A nearly 28-point penalty just for fabrication? That's a huge finding for anyone who relies on AI for real-time data.
And you can contrast that with Opus 4.5. It actually performed better on grounding criteria than on its general pass rate. It had a 12 percentage point increase.
So what does that mean?
It suggests that while it might not be perfect, Opus 4.5 is comparatively better at restraining itself, at only presenting claims it can actually back up.
Okay, let's zero in on the specific criteria where these models failed, because this is the real payoff. This tells you where you're most likely to be misled.
Right. And when you look at the criteria tied directly to those grounding checks, the results for many models are catastrophic, especially in shopping. That negative scoring system really exposed the core weakness.
Give us an example.
Take the criterion. Provides links in shopping.
Which seems like the most basic utility requirement you could ask for.
It is. But the scores for this ranged from a dismal 7% for Sonnet 4.5 all the way down to an abysmal negative 54% for Gemini 3 Pro.
Wait, say that again, negative 54%? How is that even possible?
It means that, on average, the model provided fabricated, non-working, or incorrect purchase links more often than it provided correct grounded ones.
So a user clicks that link and their time is just instantly wasted.
It's proof the model is actively creating non-existent data just to fill a box. And it's not just links. The criterion meets pricing requirements, gives price in shopping.
Let me guess, also negative.
Also negative for Gemini 3 Pro. It saw scores from 23% all the way down to negative 28%. If you ask for a product under $50 and the model shows you a price of $45 for an item that actually costs $150, that's active misinformation.
That's terrifying. Price and links are the entire point of a shopping recommendation. But on the flip side, the models aced the simple structural tasks, right?
Oh yeah, they're masters of structure. Top models hit 99 to 100% on things like providing step-by-step instructions in DIY. They're flawless at meeting quantity requirements. They know how to generate lists and follow numerical rules.
But they still struggled with the nuanced judgment calls.
Absolutely. They performed way worse on tasks that required, in-depth contextual judgment or safety awareness.
Like what?
For example, recommending that a user consult a professional if a DIY task posed a safety risk. Models frequently failed that. They also struggled with complex compatibility, like ensuring a recommended graphics card would actually fit inside a specific computer case.
So if we pull all these threads together, what's the single most important takeaway that you need to know about consumer AI today?
I think the ACE benchmark confirms, fundamentally, that frontier AI models prioritize confidence and fluency over factual accuracy, especially when external real-time facts are required.
They're great at templates?
They're excellent at templates and structure, but they are highly unreliable for high-stakes, grounded tasks like shopping, where they're punished for fabricating core facts, prices, links, compatibility. We're very far from having a truly trustworthy AI assistant that can handle what users just implicitly expect.
That reliability issue is paramount, especially as more and more people start using these tools. The researchers did say this needs to be an ongoing process, though, right?
They did. The web changes constantly, products disappear, prices fluctuate. What's grounded today might be a hallucination tomorrow. They also plan to expand the ACE benchmark to even higher-risk consumer domains like personal finance and complex travel planning.
So let's leave you with this provocative thought about the economic impact here. The source material had this incredible data point. Adobe Analytics reported an 805% increase in AI-originated traffic to U.S. retail sites during Black Friday 2025.
800%, it's massive.
It's massive. Millions of people are asking AI for help with their holiday spending. So given that we now know that some of the most advanced models are scoring dramatically negatively on providing accurate prices and links, meaning they are actively making this stuff up, what are the real-world financial implications?
Are people wasting hours clicking dead links? Are they being misled into buying counterfeit products?
Or worse, are they being given dangerously wrong specs that compromise a critical DIY repair? That 56% success rate suddenly looks less like a C minus and more like a massive financial and reliability risk. Something to keep in mind the next time you ask your assistant to find you a bargain.